settle in. Let the world outside fade away. Have you ever felt that reality itself is thin? That for a fleeting moment, the world flickers at the edge of your perception. We often dismiss it. A trick of the light. A tired mind. But what if it's something more? What if it's a sign that the very fabric of our universe is not what it seems? Tonight, we journey into a profound and tranquil mystery. We will explore the quiet whispers from the depths of cosmology. Whispers that suggest our reality might be a simulation, and that a glitch in the code has finally been found. There is nothing to fear. This is simply a story for the closing of the day. A cosmic lullaby about the nature of everything. The idea is not new. It has echoed through philosophy for centuries. But in modern times, it was given a framework by the philosopher Nick Bostrom. He proposed that one of three possibilities is almost certainly true. Either civilizations like ours always go extinct before developing the technology to create realistic simulations, or they lose interest in creating them, or we are almost certainly living in one right now. The argument is one of pure probability. An advanced civilization could create billions upon billions of simulated worlds, each one filled with conscious beings who believe their reality is the only one. In such a scenario, the number of simulated realities would vastly outnumber the one single base reality. Therefore, it is statistically more likely that we are among the many, not the one. It is a thought that has captivated minds like Elon Musk, a thought that transforms the universe from a physical place into a piece of information, an unimaginably complex piece of software. Our journey begins in silence, in the deepest, coldest observatories on Earth. Here, astronomers listen to the oldest light in the universe. It is called the cosmic microwave background. Imagine it as the afterglow of creation, a faint, residual heat from the Big Bang, bathing everything, everywhere, all at once. It is the universe's first photograph, a baby picture of space-time itself, taken when it was just under 400,000 years old. For decades, we have studied this map of ancient light, finding patterns that tell us the story of our cosmos. This ancient light is not perfectly uniform. It has tiny variations in temperature, like faint ripples on a still cosmic pond. These ripples are immensely important. They are the seeds from which all structure in the universe grew. Every star, every galaxy, every cluster of galaxies can trace its origin back to these minute fluctuations. We thought we had mapped them perfectly. We believed we understood their gentle, random nature, the signature of a natural, chaotic birth. But we were looking at the grand picture, not the finest details. A new generation of instruments allowed us to zoom in, to enhance the resolution of this cosmic photograph to a degree previously unimaginable. And there, in the deepest layers of the data, something unexpected appeared. It was not a grand, sweeping feature, but a tiny, persistent anomaly, a pattern so subtle it had been dismissed for years as instrumental noise, a ghost in the machine. But it refused to disappear. With every new observation, it was still there, a whisper in the cosmic static. Imagine you are listening to a recording of a vast, empty wilderness. You hear the wind, the rustle of distant leaves, the sounds of nature. But if you listen closely, very closely, you might hear a faint, repeating hum, a tone that does not belong. This is what the scientists found. A recurring, grid-like pattern of temperature variation in the background radiation, a pattern that was just a little too regular, a little too organized to be a product of random chance. It was as if the canvas of the universe had a watermark. This pattern has been given a quiet, unassuming name by the teams studying it. They call it the cosmic quantization effect. It suggests that at the most fundamental level, space and time may not be smooth and continuous, as we have always believed. Instead, they might be made of discrete, indivisible units, like pixels on a screen, tiny, fundamental building blocks of reality, so small that we would never perceive them in our daily lives. But on the scale of the entire cosmos, their collective effect might just become visible. The implications of this are profoundly calming to consider. If the universe is composed of fundamental units, it means that it is, in essence, digital. It operates not on the infinite, flowing mathematics of the analog world, but on the finite, calculated logic of a computer. Every interaction, every particle, every force could be the result of an unimaginably vast computation, a set of rules, an algorithm playing itself out over billions of years. And every computer system, no matter how complex, has a fundamental resolution. Think of a photograph on your screen. From a distance, it looks like a perfect, continuous image, a smooth gradient of color, a seamless reality. But as you zoom in, closer and closer, you begin to see the individual pixels, the tiny squares of red, green, and blue that create the illusion of the whole. The cosmic quantization effect could be us, for the first time in history, catching a glimpse of the pixels of our reality, a flaw in the illusion of a perfect, seamless universe. Scientists first tried to explain this pattern with conventional physics. Perhaps it was an undiscovered law of quantum gravity. Perhaps it was the faint echo of colliding cosmic strings from the dawn of time. But none of the models fit perfectly. The grid-like structure was too uniform. It resembled something not from the natural world, but from the world of information technology. It was reminiscent of a compression artifact, the kind you see in a digital image that has been saved with too little information. This is where the simulation hypothesis re-enters the conversation, no longer as a philosophical game, but as a potential physical model. In a simulated universe, resources would not be infinite. The system's programmers would need to optimize their creation. They wouldn't render the universe in infinite detail everywhere, all the time. That would be computationally impossible. They would create shortcuts, efficiencies in the code. A fundamental grid, a base resolution for the canvas of space-time, would be the ultimate optimization. This subtle pattern in the cosmic afterglow could be that grid, the underlying framework upon which our reality is rendered. We do not see it because the pixels are smaller than anything we can measure directly, but their faint collective signal, a tiny repeating error, might be imprinted on the oldest light in the universe, a signature left by the system's architecture. It is not a bug, perhaps, but a feature of the operating system. Let's explore another piece of this cosmic puzzle. For years, physicists have been perplexed by certain universal constants: the speed of light, the strength of gravity, the charge of an electron. These numbers appear to be finely tuned to allow for the existence of life. If they were even slightly different, the universe would be a sterile, empty place. Stars would not form. Chemistry would be impossible. We would not be here. This is known as the fine-tuning problem. Some explain this through the multiverse theory, the idea that there are infinite universes, each with different constants, and we simply happen to exist in one that got it right. But the simulation hypothesis offers a simpler, more elegant explanation. The constants are not random accidents. They are chosen parameters. They are the initial settings input into the system by its creators to see what kind of universe would emerge. We exist because our universe was programmed for existence. Now, consider the newly discovered glitch in this context. Recent, ultra-precise measurements of these fundamental constants have yielded another mystery. They don't seem to be perfectly constant. There are minute, almost immeasurable fluctuations over vast cosmic timescales. It's as if the system is experiencing a tiny amount of jitter, a slight variation in its processing, like a computer's clock speed wavering under immense load. This is the second part of our glitch. Not just the pixelated grid in the background, but a wavering in the fundamental rules. Imagine a video game. The physics engine that governs how things move and interact is normally stable, but in a truly massive, complex simulation, tiny rounding errors could accumulate over time. The 100th decimal place of a constant might flicker. It would be imperceptible to the characters inside the game, but an outside observer might notice the slight instability of the code. These two findings together, the spatial grid and the temporal jitter, paint a fascinating picture. They are exactly the kind of artifacts one might expect to find if looking for evidence of a simulated reality. They are not grand, obvious errors, but subtle, systemic properties that hint at a computational foundation. They speak of a universe that is calculated, not just existing. A world that is rendered moment by moment, pixel by pixel. This brings us to the strange world of quantum mechanics. At the subatomic level, reality behaves in ways that defy all common sense. Particles can be in multiple places at once until they are observed. The act of looking at something seems to change what is there. This is the famous observer effect. It is as if reality is not decided until a conscious mind forces it to choose. For decades, this has been a source of deep philosophical unease. But from the perspective of a simulation, it makes perfect sense. Think once more of a computer game. The game world is vast, but your computer does not render every single detail of it all at once. That would be a waste of processing power. It only renders what is in your character's line of sight. The landscape behind you might exist only as a simplified set of data. When you turn around, the system quickly loads the high-resolution textures and models. The world solidifies upon being observed. Could the quantum world be operating on a similar principle of resource management? A particle exists as a wave of probabilities, a set of data, until a conscious observer interacts with it. This interaction is a query to the system, which then must render a definite state for the particle. The observer effect, then, is not a mystical property of consciousness, but a practical feature of a resource-optimized simulation. Reality is loaded on demand. And what of the speed of light? We think of it as the ultimate speed limit of the universe. Nothing can travel faster. Why should there be a speed limit at all? In a purely physical, infinite universe, such a hard cap seems arbitrary. But in a computer simulation, it is a necessity. The speed of light would be the processing speed of the cosmic computer. It is the maximum rate at which information, and therefore causality, can propagate through the system. It's the refresh rate of the universe. The glitch we are discussing, this faint, grid-like pattern, can be thought of as the distance between the nodes of this cosmic processor. And the jitter in the physical constants could be the slight timing variations between processing cycles. Every part of our universe, from the quantum dance of particles to the hard limit on speed, begins to look less like a cosmic mystery and more like a feature of a brilliantly designed piece of software. Let this thought gently settle. It is not meant to be alarming. It does not devalue our existence. A simulated life, a simulated consciousness is no less real to the one experiencing it. Our love, our joy, our sorrow, our curiosity, they are all real data. They are meaningful within the context of our system. A story written in code is still a story. And this story, the story of our universe, is the most magnificent one we can imagine. This discovery of a potential glitch does not provide definitive proof. It is an anomaly, a single, strange thread in an impossibly vast tapestry. But it is a thread that, when pulled, begins to connect many of the deepest puzzles in physics into a single, coherent narrative. It offers a potential explanation for the fine-tuning of the universe, the strangeness of the quantum world, and the ultimate speed limit of reality. Imagine the programmers of this simulation. They are not gods in the traditional sense. They might be scientists from another universe, running an ancestral simulation to study their own past. They might be artists, creating a universe for its aesthetic beauty. They might even be children, running a simulation on a computer we cannot even conceive of as part of a school project. We may never know their motives, but they left a trace. In their quest for efficiency, in the very architecture of their creation, they left a watermark, the faint grid in the cosmic dawn, the slight tremor in the universal laws. These are not mistakes. They are the brushstrokes of the painter, the fingerprints of the programmer. They are the seams in the fabric of reality, visible only to those who look closely enough. Does this mean our lives are predetermined? Not necessarily. A simulation can be a closed system with initial conditions and rules, but one where the outcomes are emergent. The programmers may have set the stage, but the play is written by us, the actors. Our free will could be a core feature of the simulation, the very thing they wish to study or observe. We are the random number generators, introducing genuine novelty into their system. And what lies outside the simulation? This is a question that lies beyond the reach of our science. It is a peaceful question for the quiet of the night. Is it another higher reality? Is it an endless series of nested simulations like Russian dolls of existence? Or is it nothing? Just the hum of the cosmic hard drive, sitting in a room we can never enter. There is a strange comfort in not knowing. The discovery of this glitch does not change our world. The sun will still rise. The seasons will still turn. But it can change our perception. It can instill a sense of profound wonder. To look up at the night sky and see not just a random scattering of stars, but a magnificent, rendered image of incredible complexity. To feel the breeze and wonder about the algorithms that govern fluid dynamics. It connects us to the universe in a new way. If all of reality is information, then we, as conscious beings who process information, are not separate from the cosmos. We are a fundamental part of its operation. Our consciousness is not an accidental byproduct. It is the way the universe observes and understands itself. We are the universe's way of running a diagnostic on its own code. So as you drift deeper into relaxation, into the quiet space between wakefulness and sleep, hold on to this idea gently. Let it be a source of calm, not anxiety. The universe is a grand story, a masterpiece of programming, and we are privileged to have a role in it. The faint glitch in the background is just a reminder of the magnificent artistry that surrounds us, even in the deepest, darkest silence. Perhaps sleep itself is a feature of the system, a nightly log-off to defragment our own consciousness, a time when our data is backed up to the main server, and perhaps dreams are the screensavers of the simulation. Random, beautiful patterns generated while the core system is at rest. There is a poetry to this thought, a gentle logic that can guide you now into a peaceful, trusting rest. And so, our journey through the code of the cosmos comes to a gentle close. We have seen how a faint, grid-like pattern in the oldest light of the universe, combined with a slight wavering in the laws of physics, could be the first tangible hint that we are living inside a vast computational system. This glitch doesn't break our reality, but instead, it illuminates its possible structure, connecting the mysteries of quantum mechanics and the fine-tuning of the universe into one breathtaking idea. It transforms the cosmos from a random, physical place into a deliberate, informational masterpiece. It is a beautiful thought to fall asleep to. The idea that our world, in all its complexity and wonder, is the product of a mind-bogglingly advanced intelligence. That we are, in essence, living inside a work of art. Thank you for joining this tranquil exploration tonight. If you found a moment of peace or wonder in this story, please consider liking this video and subscribing for more lectures for sleep. As you drift off, I leave you with one final thought to ponder in your dreams. If you could leave a single, simple message for the programmers of our simulation, what would it say?